So, today I'm going to bore you with the topic development is not only about writing code anymore. Just a quick disclaimer, this is my first opportunity to be presenting on a live venue, so get ready for a fiasco probably. A little bit about myself, I'm a Java developer at Mitov, been part of the company for about 3 years and a half. I'm a big Kotlin lover. I actually started my career with the language, implementing a OAuth 2 library directly on the. It was tailored directly for the Google App Engine. So at an early stage, I was taught to think about security first and implementation later. Mainly worked on microservices on Google App Engine, as I mentioned, AWS as well. I had the opportunity to work with legacy things like gRPC. I've worked with Kafka, with PubSubs. Had the chance to explore the world of ActiveMQ and RabbitMQ as well, just for comparisons. In my spare time, I love playing board games. I'm an amateur drone pilot. I love checking Bulgaria's beautiful nature from a bird's eye view, and also been dabbling into a little bit of wood carpenting. But enough about myself. So, as I said in the past, you might have developed an application all by yourself with little to no interaction with anybody else from the outside world. But nowadays, the picture is quite different. To be able to work efficiently, to be able to develop, you need a wide set of skills, both technical and soft ones. The agenda for today, I need to click twice with this. We're going to talk a little bit about the big picture. I'm going to show you a project study about the project I've been working right now for the past couple of years. A little bit about the tools we use, the pipeline and how it's being set up, about how we do documentation and communication and why I think it's super important to do that. A little bit about the soft skills and some time for Q&A if you guys want to. 2 clicks for forward. So, as we said, the developer did everything by himself. Wrote tests, did some development for new features, grabbed that obese WAR file, jar file, whatever you choose, slap it right there on the web server or the application server, and like you would do everything by yourself, or probably you might have a DevOps guy if you still haven't gotten on his nerves. But the picture today is quite different though. With the exponential growth of the usage of cloud computing, the need to understand more and more out-of-the-box solutions grows as well. And you have to understand that, at least I've understood that cloud is the future and it's going to stay there. The latter usually solve things like problems from the past, like load balancing, like caching some data in your servers, in your database, scaling your application architecture, even going as far as optimizing your code for scalability and maintainability with static code analysis. And of course, improving the code. So here, Gartner Incorporated, a partner of ours in Mentomate, has made a very interesting graph showing, it was part of a study where they asked a couple of HR firms how much of the functionality nowadays is hosted on the cloud and how much of it is on-premise or maybe both. And as you can see, the HCM, the Human Communication, let me just double check so that I don't butcher the Human Center Management Administrative HR functions. About 43% of them are already completely moved to the cloud. 26% are on-premise applications, and 30% are both on cloud and on-premise. The other side is 61% for all the talent management has completely moved to the cloud. The other ones are grayed out because they don't serve my survey, so we don't need them. So the amount of work and people involved in developing an application has grown exponentially as well. So we usually stand on this right side over here, which is the development part. But before any requirements even get to us, we have A lot of teams of business analysts, architects, and designers as well that go through thoroughly over the client's needs, and they make it so that their needs are the right ones. They make it so that it's easy to understand for them, but also for us when we try to develop the application. So, all the project documents arrive, we have Jira access, GitHub repos are being made, and we're ready to Lingo. The project manager huffs, the team leader puffs, and we go through countless iterations of developing new code, new features, and some spicy bugs to accompany them. So countless iterations, as I said, pass. We have some overtime and years later, the client demo comes. So at that stage, we receive valuable information, some feedback, and we are ready to go back into delivering features. So usually we'll work with Agile, Scrum, Kanban, sometimes Scrumban, if we are too lazy to write the carryover reasons in our Jira tasks. So I would just like to emphasize a little bit about this part down there. It's usually like we are up here, we're okay, we just do bug fixes, enhancements, so on and so on. But when we're developing an application, we always need to think about how we're going to monitor it, how we're going to implement, how we're going to keep that onion safe, and at the inevitable future, how our clientele of the app actually grows, and we need to be ready to scale with it as well. So, as I said, we're going to talk a little bit about a project that I'm working on right now. From some of the numbers that I'll share with you, you're probably going to say that this isn't even a big project, and you'll actually be right. Even at the mid-scale, the technology stack sometimes can explode into knowing how to write databases, to implement different patterns like CDC, to have you'll have to work with data lakes, cloud technologies, move to event sourcing at some stage, write webhooks to your Slack channels, and so on and so on. Our project is developed on GitHub, at least as a source control. We use Jira as work manager and Notion as documenting everything, and I do mean almost everything. We have dedicated Java teams that work closely with quality engineers, and together with the front-enders, we just make sure that everything has the exact amount of makeup for our clients. We store data for our data engineers so that they can work their data shipping magic. We have DevOps teams that make sure that this whole mess is kept together. We have Scrum Masters that, alongside with the delivery lead, work closely together with the POs so that this whole circus is fine. So the Java side, as I mentioned, we use Java 11. It's using the OpenJDK 11.04 version. And we are also using Spring for that amazing boilerplate evasion that it provides. We use Spring Boot for the inversion of control, of course. It's magical. Nobody wants to write new anywhere. We have Spring Data in Hibernate to manage our daily SQL queries that we don't have to write anymore. And Hibernate gives us that sweet level to cache and session management. We have Spring Security to keep our Lognon safe and sound, and so that we can get authorized. And Spring LP is used from time to time to insert aspects here and there. They're super magical. Databases and data engineering. As I mentioned, so Spring, we cannot let everything to be managed by Spring, and we have a dedicated team of database data engineers. And by dedicated, I would like to put big quotes there, because at some point we're actually asked, hey, do you want to develop AWS Glue, or maybe you want to write some Ascent, Databricks? And it was interesting for us, so we kind of grabbed it and started working with it. And here we're creeping a little bit about what this whole presentation is about. we signed up to be just regular as back-end engineers. But the more the application just scales up, the more there are different niches that we need to fill up to be able to continue developing. We have to be database architects, as I mentioned. We need to consider relations between our different models, and most of the time you don't even have dedicated database architects. You have to do it yourself. You need to think about connection pooling. You need to think about how different transactions are going to be operated on regarding that connection pooling, and we've had many problems before. You need to think about optimization, about different cascading operations that need to happen regarding on different other operations that are happening. The PostgreSQL composite indexes became our best friends. Redis is our caching master that we're using, and like many others, we're just using it because of its amazing fast response times and the ability to wildcard match different responses. We're also using Elasticsearch for its full text search capabilities that are completely document based. And of course, it supports auto-completion, which gave us the ability to provide our users with a type-ahead search capability, which immensely improved their day-to-day lives. So, as I mentioned, we have AWS Glue, which is our core technology for manufacturing ETL jobs. ETL means extract, transform, and load, which in the present times with the amount of data going usually throughout the client application is a must. We have been dabbling to migrate the Glue jobs to work with Ascent and Databricks. The Databricks Lakehouse platform of itself allows us to store all of our data in a lake-like structure and perform different AI and BI operation on top of that. It has directly SQL performance optimizations like indexing, like caching, and massive parallel processing. Excuse me. On the other side, we have the Databricks Lakehouse platform, which, again, it's a similar lake-like platform that gives us, Starburst was the only thing left. My mistake. Yeah, Starburst is our all our data warehouse. It has the capability to be our facade for that massive parallel processing that feeds the data for Ascent and Databricks and Glue as well. Of course, every self-loving application nowadays cannot call itself scalable and modern if it doesn't implement event sourcing. So we decided to use Kafka. Of course, I don't know, probably love it because of, I'm going to quote it, 1,000 brokers, trillions of messages per day, petabytes of data, hundreds and thousands of partitions. We use event sourcing to trigger different extracts asynchronously using a tool called MFT, which is of itself a glorified file system. It can actually observe different folders for files popping in and out, and that can trigger cron-like jobs so that it can execute operations regarding what happened with the files. We are also considering on my current team implementing a pattern that is somewhat loved and hated called CQRS, Command Query Responsibility Segregation. That's a whole topic of itself, but it's an amazing way that you can scale the reads and writes in your application separately and be able to actually use a separate dedicated databases for both operations. So, of course, all of this wouldn't be possible without the magical cloud. And most of us are not even AWS certified, but at this stage we might as well could be. We're implementing different out-of-the-box solutions for different architectural problems. We take advantage of the whole cloud ecosystem with its separation of concern and isolation. And even a colleague of mine made a joke about it, that you can think as microservices being actually deployed to microservices. In our case, we use a multitude of the cloud services. We have the ELB, which is the Elastic Load Balancer. Whoever knows what a load balancer is, it provides that. You can, it can work somewhat of like a round robin or like service discovery, depending on what choice you make and what metrics you feed it. We're using S3 as that amazing file system that AWS provides. It's its domains are separated by buckets, so that you can have that isolation between different environments, different production stage, whatever you want. Next on the list is AWS CloudWatch. Every application needs an overload to check what's happening, and CloudWatch is there to deliver. It can observe what's happening with your application on a daily basis and provide different logs and metrics so that you can attach them to other services. RDS is there, and it's been responsible for all of our relational problems. It has debugging capabilities like providing reporting on how much time it took for your query to run. It checks for if you extracted too much data on a query because of that infamous N+1 problem. And it's just amazing what it does, but at the same time, it's one of the most expensive AWS services, so you need to deepen your pockets if you want to use it. KMS is next, which is the amazing service that stores all of your cryptographic keys in one place. It has a secure and resilient hardware protection, and all of your keys are actually accessed by privileges and roles. So you don't actually have access to your keys, but they're still there. Next on the list is AWS Secrets, because AWS works in mysterious ways. It's even more secrets. It's a key value-based store, which directly implements with the KMS service, which itself serves as having that SSS rate for any of you Devil May Cry fans, super safe, secure in our case. We use DynamoDB as well, because not everything needs to be relational, and AWS has an out-of-the-box implementation of a non-relational database. I haven't actually mentioned this, but we also use ECS, which is the Elastic Container Service. It works out of the box with Kubernetes or Docker, and you can just tell it which images you want it to scale up, and it's going to do it for you. It's going to rescale new ones if need be. It has covered. Next on the list is the ECR, which is the Elastic Container Repository. It is there to contain our images themselves, the ECS images. And last but not least, we have the EC2 instance, the EC2 instance, somewhere said. It's the Elastic Cloud Compute. Those are the virtual machines of AWS themselves. They are used to run absolutely everything. Like we have our Kafka and Zookeeper runs there, our services run there, our Jenkins runs there, absolutely everything is there. And to keep everything cloud ready, we use Terraform and TerraGrunt to apply their special scripts. Double click. So, testing this mess. When talking about, even with a dedicated team of quality engineers, some people still ask the question whether or not you need to have dedicated unit and integration tests. And my answer would always be yes. They provide an amazing safety net that not all of the FTAs should be catching. We'll talk a little bit about that later. We use JUnit 5 for our day-to-day unit and integration tests, and Mockito to mock, of course. Our quality engineers themselves write the fully test automation. I'm going to be calling them FTAs, using Groovy and Cucumber with Gherkin. Just Cucumber and Gherkin are just an abstraction for how you want to write your tests so that they fit the business scenarios. It's just an abstraction over it. And that way we have complex and automated tests that run our that test our application end to end. Of course, we have Selenium here as well, which is of those complex front-end interactions that may happen, authorization to, different automated front-end interactions. So I would like to state out that the FTAs are very good at catching different end-to-end test scenarios when talking about when working with microservices, because it's actually pretty hard to directly test the integration between the microservices, and FTAs themselves just spin up an environment and test end-to-end. But at the same time, sometimes when run asynchronously, they can have very flaky behavior. So that's why we decided to shift left a little bit with our quality engineers, and we started meeting regularly, identifying what our different business scenarios are, what the different niches that we want to test are, and we made it so that the quality engineers more so tested the happy paths or the critical paths, and on the back-end side, we tested more of the validations and the different scenarios that weren't considered so likely to happen. But again, we need to have both of them working together, so that's why we have the pipeline dynamic duo. So every time you need to run your tests locally, that's a given. But we do forget to do that all the time. And that's why we need to have a CI/CD integration that needs to happen before each and every iteration, before merging something in stage or master, or before it gets to production. In general, here we chose Jenkins as our continuous integration, continuous delivery tool. It makes sure that the whole pipeline itself goes as this. It compiles our code. It makes sure that all of the back-end unit tests are run, and front-end tests are run. After that, we have all of the FTAs. After that, we have that code actually deployed to a ready-to-use automation environment where we run all of the FTAs asynchronously, as I mentioned, and it's almost all of the FTAs, and I'm going to elaborate on that. By almost, I mean that we've actually implemented something interesting here. So as I mentioned, running everything all the time can be slow. So we decided to identify what the new functionalities are and just use the FTA specs to be run only for that. But that doesn't mean that if you don't change some code for about 2 years, nothing will be run for 2 years. We actually implemented it so that all of the FTAs need to run before merging into stage or master, but before deploying to stage or production. But at the same time, one is just releasing new features, merging them to master is just part of them. So after Jenkins has finishing doing all of this, we are actually using SonarQube for its to enhance our workflow for better code quality. It has improved security scanning. It has in-depth analysis for to improve scalability and maintainability. And to top it all, it also gives you a code coverage report that you can later use for whatever you need. In our case, we use it to pass something. I'm going to talk about that. It points out potential bugs as well and tells you what are the potential fixes for it. It identifies duplicated code. It has a security vulnerability that it can identify for you. And it's fully integrated with Jenkins and actually works with other languages aside from Java as well. So for you to have a green build and merge something into master, you actually need to have the Jenkins passed with all of its FTAs, with all of its unit tests, you need to have a SonarQube quality of code coverage of at least 80%. And something interesting, like no bugs, no potential security vulnerabilities, or I guess you can mark some of them as safe if you think you know better, but it still goes throughout a review. And at the end of the day, we even implemented Jenkins here so that GitHub actually checks whether or not all of the subtasks were actually completed. And if they are completed, green build. Like there is a backup door there, like you can mark something as a post-release, but still, like it needs to have everything, every subtask completed before you merge into master. So for this, my t-shirt says as well, keep your pitchforks and tomatoes just for a bit. And why I think that Stack Overflow is a little bit overrated. So it's you might think that I'm arrogant or impudent or like why is he touching a so well time-tested and pristine platform? And here I would like to say that, yes, I've had countless times that I had the solution coming from Stack Overflow. And when you read about developers online, we are 90% spending our time on Stack Overflow, copy-pasting code, or that we're actually glorified Google searches. But what I'm saying here is that Stack Overflow actually needs to be your second place to search for a solution, the team being the first one. We ourselves need to be the ones that communicate what our problem was. We need to document it, we need to document how we solved it, and we need to inform everyone on what the solution was, so that way we can actually become a pipeline of improvement of ourselves in the team. So, of course, when talking about communication, not everything can be just communicated. Given that lately with the global pandemic, we've been mostly working from home and we've been isolated, and all of our communication goes through channels anyway, so it's the best time to keep everybody informed on what's happening right now. So we need to start with documentation before we even get to the communication. And all of our processes need to be written down and reachable for everyone. That's why here we're using Notion, but I've also stated out a couple of others that are used for sharing information between the teams, like S-Lite, Confluence, Coda, Nuclino, all very good implementations of documentation platforms that you can use to share information in your team. Each and every team has a dedicated page or pages where a developer can very easily, when joining the team, can get up to speed on what the business requirements are and why something's happening there. So when I joined the project at the start, I was very pleased to find out that page, which actually answered a lot of questions that I had, and actually a lot of others that I didn't even think that I wanted to ask. And that's why it's a must to have an onboarding material for all of your new developers, be they seniors or juniors. It's a given, it's a must. Aside from that explanation that we just talked about, we have what a software development lifecycle is, what are different definitions of done mean, who you need to bug if you have to make a change into a separate domain that's not the concern of your team. Stuff like that are a part of our Notion documentation. We also keep a very because as I mentioned, we implemented event sourcing, and microservice-based architectures using event sourcing actually tend to get very messy and spaghetti codey. So the relations between your different producers and consumers can get very messy, and having very well implemented sequence diagrams can help you understand why you wrote something 2 years ago. Also, talking about microservices, we have, like as I said, we have 20 microservices with 5 domains. So those orchestrators actually call different underlying domains, underlying microservices. That thing is a perfect place to implement the different sequence diagrams, understand what the business logic is, and when you have to make a change. The project that I was talking about is in the health industry. And we've worked constantly with file formats like X12, 834, 835. And those are normal industry standard files that you wouldn't have actually heard about them before getting to them. So having, again, that documentation, and I'm just going to keep saying, having that documentation there for everyone to be able to understand why something was written like from in your string from space 0 to 36, that's the member ID. From space 37 to 39, that's the first 6 digits of your member name. First 6 characters of your member name, and so on and so on. So it makes us write code that we don't actually like, but at the same time you have everything documented, and if you have to make a change to that spaghetti-looking code, you know why it's there. And that's info directly from the vendors, directly from different clients that we'll be working on, and you know who you should contact from a vendor, for instance, if you want to have to make a change to that. Of course, after documentation, we need to talk about communication. We use Slack as a base form of communication, where every team, as I mentioned, they have a separate domain or domains, of course, channels, where they can communicate the latter mentioned problems that they have on a day-to-day basis, how they fix them, and other people can come in and just see what's happening with the team right now. Also, we use directly Slack webhooks to implement what our different extracts are doing, if that deploy to the stage environment actually passed or the team environment failed for some reason. We get constantly notified by the different sources in a single place, Slack in this case, but you can use absolutely everything that has an implementation with webhooks. We also got on the Zoom bandwagon. I have no idea how Microsoft messed Skype and left Zoom just come into the business, but that's their problem. Zoom has amazing implementations with a whiteboard with the latest release, I think, or at least they fixed most of the problems that we had in the past. So the whiteboard right now is our go-to place to sketch out different sequence diagrams quickly. You can very easily show your PO what the different microservices involved in the current problem are and how the communication between them is going to happen. So as I said, we tend to get together for all the different ceremonies like stand-ups, refinements, and so on and so on. Something I missed for the documentation part, and something that a team of ours recently did, and that is actually amazing, is they actually did a templatization for the refinement process. Right now, whenever something, even before it gets to refinement, somebody from the team grabs it. There's public, at least for the teams, place where you can assign yourself to the task. And the other amazing thing is that you can actually use a variety of templates for each and every possible subtask that you might have, so that whenever you start to refine your backend task, for instance, you can just you can just check those questions that have been marked down in the template, and you can see, do you need to write an endpoint, what the URI needs to be, what the JSON body needs to be, if you need to implement event sourcing, logging, new documentation that needs to happen after the task is done. Absolutely everything is written down there, and that way, whenever you start to refine something, because it's very easy in your day-to-day life to just forget to add some different small details to our tasks, and that's why using these templates actually helped us refine our task immensely. Since I have a couple more minutes, something that we're doing in Mentormate, and it's a must, is before being able to give your input on any idea or persuade your PO or team lead that hot new technology actually needs to be implemented, or it's the right tool for the job. You need to have a variety of soft skills at your arsenal. We need to be able to speak the technical terms perfectly, but also speak the business lingo as well. So that's why here at MentorMate and I'm not saying this like we are the best and so on and so on. I'm just saying that I think that we should be doing it everywhere, and we should be running different skill set trainings so that we can improve our colleagues in their day-to-day life. We have a presentation skill training which tells us the do's and don'ts of the spotlight. It gives us the ability to understand what to do and what not to do. We have a client satisfaction and communication training which tells us how to do proper demos, how to handle different scenarios, like the PO just suddenly started crying during a demo. What do you do? And those became different scenarios that we got prepared for, and are problems that you wouldn't usually see in Builder, in Stack Overflow, or in DoubleTree schools, for instance. Not everybody is perfect, so we got taught how to receive proper feedback and how to give proper ones so that we can help our colleagues to improve as well. Keys to productivity, which immensely helped us to actually understand how to manage our time, how to manage stress, how to manage whatever's happening in this crazy world right now. We had a training for effective remote teamwork. Of course, almost everything moved to working from home, so we had to learn how to be social without being social. Something interesting from this training that I wanted to quote from Henry Ford is: coming together is a beginning, staying together is progress, and working together is success. We had a mentoring skill training, which was directly intertwined with the giving and receiving feedback, which helped us to teach our colleagues and become a pipeline for improving, for coaching. We got introduced to Radical Candor, which is a whole book that you have to delve deep of itself, like best next time methodologies and so on and so on. Interviewing skills, of course, how to choose your new colleagues, how to be able to conduct proper interviews, and how to be able to make it as easy as possible for the interviewed himself so that he doesn't get stressed and be unable to actually show all his skills. And there we had a leadership course as well that was tailored directly for the future generation of management, and it's giving us the pitfalls and hardships of the usually lightly overlooked position. So when everything actually comes together, it might look something like this, and this is courtesy of Gauss, which is an amazing tool for representing your code bases. I found it very interesting to see a visual representation of your GitHub repository. If you want to run a similar visualization, you can just download Gauss and run it in your code base, in your Git locally, in your Git folder, and it's going to generate that for you. Just it doesn't actually have a screen capture capability, so you would have to use a third-party application to capture that. So, as a finisher, I would like to share with you one of my favorite sayings, which is a jack of all trades, master of none. It is something that I think each and every one of us needs to think about when developing and when learning new things. Most of the people know this saying to this part, and I wouldn't blame you. It took me years to actually understand that it has an end part, but better than master in one. So you need to be as flexible as possible in this growing world of technology and constant social interactions. And thank you for your time. If you have some questions, I want.